Hi, now we are going to discuss about a new theorem known as Norton's theorem. Okay, suppose we have a circuit that contains so many resistors, voltage sources, and current sources. Then that will be difficult, very comparatively very difficult to find the um, current or voltage drop across a particular branch. In that case, we can make use of this theorem and Norton's theorem. Okay, right. This theorem states that suppose the given circuit, suppose our circuit contains more number of resistances, voltage sources or current sources, whatever it may be, we can convert that complex circuit into a single circuit that contains a current source and a resistance that should be connected in parallel with that current source. Okay, right. Simply speaking, if a complex network, complex in the sense it contains so many voltage sources and current source resistance, can be replaced with a single circuit consisting of a current source in parallel with the resistance. Okay, right. Now a question may arise: how can we find that current source and that single resistance? Okay, the current source is the short circuit current between the two terminals of the network, and current in the sense that current should be the short circuit current between 2 points. I will explain what is the meaning of these 2 points. Okay, right. And the resistance is equivalent resistance measured between those two terminals. Notable thing is current source is the short circuit current, and the equivalent resistance is the resistance is the equivalent resistance measured between the terminals. Okay, right. Now I'm going to explain using a circuit. In this case, the care should be noted that we have to replace all other current sources and voltage sources by using its internal resistance. Now consider the circuit. This circuit has a single voltage source V, and resistances R1, R2 and R3, and a single current sources. Okay, suppose that network has one more current source, say V2. This this circuit can be replaced using a single circuit containing a current source. This is the representation for current source. And what is the statement? Can be replaced by an equivalent circuit consisting of a current source and resistance that should be in parallel. Okay, right. That is the Norton's theorem's statement. So we can represent this entire circuit using a current source and a parallel resistance. Okay, parallel resistance. And this current should be the short circuit current. Suppose we have to measure or suppose we have to find the Norton's equivalent circuit between this point A and B. Okay, the current is known as Norton's current, and that resistance is Norton's resistance, that is the equivalent resistance between terminals A and B.